All right, everyone. Welcome to week 5 of the Azure Cert Prep. Thank you all so much for your patience in me getting this video out. And today we will be talking about blobs, data lakes, files, and tables. This week is relatively a more simple week compared to the discussion that we had on relational databases, OLTP, OLAP solutions, because honestly, the very first thing that you interact with as a user of any computer is really unstructured data, specifically binary data, right? Think back to when you first hopped on a desktop or a laptop. What were the kind of files that you were interacting with? Text files, doc files, Excel files, images, videos, things like that, which really at its heart are all binary large objects. So with that, let's dive right in and see how we can interact with these files via Azure. All right, let's skip through this review. We actually already talked about this. Let's actually, before we dive into blobs, let's review a little bit of content from last week. So last week, I talked about stored procedures as a possible object that we can use in our relational databases. But I really want to differentiate what a stored procedure is versus what a function is. So a stored procedure in SQL, which is this guy right here, is essentially something like a function or a batch of queries that can modify tables, they can execute functions, and optionally, they can return values. Basically, think of stored procedures as a bundle of logic that you create in order to make your job easier, right? Let's say you modify your table in some specific fashion every single week. Well, stored procedure is probably what you want to go for, right? Now, function, this is a little bit different. When we say functions in SQL, I want you all to think of those aggregate functions that we have in our queries, right? Like, for example, sum, count, um, so on and so forth. Functions are bundles of logic that cannot modify tables, and they cannot execute any other procedures, and they must return one singular value or a table. So notice the difference between procedures and functions. Procedures are logic, that we use to modify tables, whereas functions in SQL is logic that our logic is logic that we use in SQL to return some specific value. So that's really the difference between procedures and functions, and it will help for you to remember that during your DP-900 exam as well. All right, now that we got this out of the way, let's talk about how we actually set up Azure services. Now, we talked about some of these services already, but how do you actually create these services, right? What do? Do you just like log in to Azure and that's it? You just start creating services? Well, not necessarily. Services, everyone, are managed through things called subscriptions. Now, if you are just one person by yourself and you are looking to play around with Azure, most likely what you're going to do is you're just going to create one single subscription. You're going to put your email, your credit card, and then you're basically ready to go. That's the beauty of cloud, right? You don't need to have a huge on-premise solution or servers that you need to spin up and hire someone to figure out how to spin up and maintain and administrate. No, all you need is a credit card and hopefully someone that's knowledgeable enough on the cloud platform that you're using in order to use the actual tech that we're aiming for or create the tech that we're aiming for. Anyways, so subscriptions, those are the basic levels of subscriptions. Those are usually the initial setup that we have. And notice that I kind of skipped management groups. And that's because you can think of management groups as essentially email accounts, or rather, when entire organizations want to manage various subscriptions, right? So for example, if you're setting up Azure by yourself, you really don't need a management group. All you need is just a subscription. However, if you are part of a larger organization like the Knowledge House, and let's say this subscription belongs to the data science account, well, maybe you'll have another subscription that belongs to the cybersecurity account. And that makes sense, right? Because sometimes you don't want services to interact with one another, or rather, there's specific information that you want to keep private, or only made accessible by privileged users. So it would make sense why you would separate out your services in various subscriptions. Now, underneath subscriptions, we then get even more granular and create something called a resource group, which is just essentially a grouping of various Azure solutions. And then if you go even further, resource groups finally have resources. So for example, maybe one resource group has the SQL service, whereas another resource group has other services such as like this analytics pipeline or whatever. Now, something important to note is that we have the ability to communicate across resource groups, and that's quite important, right? Because let's say you have this analytics pipeline. Well, preferably, you would also want to connect this analytics pipeline to a relational database so that you can pull data and do all your fancy analytics work. Anyways, so that's the basics of how to set up Azure services. Hopefully, we'll actually be able to play around with this in an actual Azure platform. Now, let's actually skip this review question. Let's jump right into blob storage. So we talked about OLTP, we talked about OLAP. Now we get to talk about blobs, binary large objects. First off, what is a blob file? Is it semi-structured, unstructured, or structured? Well, hopefully the name blob even evokes the idea of an unstructured data format. Essentially, a blob is an acronym that stands for binary large object. And this basically states that, or it basically indicates that this is a type of data that has no inherent structure, or rather, no easily interpretable structure, and you need some sort of specialized software to understand. This could be various documents, images, audio, video, or other binary data, maybe even Git commits. And oftentimes, if you were to try to open up a binary large object, this is what you would see. Just a whole bunch of binary data or data that represents binary data. I think this is in hexadecimal. Anyways, so what do we do and how do we store binary large objects in Azure? Well, we create something called a blob container. Well, rather, even before we get into blob containers, let's talk about Azure storage. So within Azure storage, we can create something called a blob container. Now notice that blob containers are not the only drop-down menu item. There's also file shares, queues, and tables, which we won't talk about for now. For now, we're just focused on blob containers. So within blob containers, everyone, or within Azure storage, we can create various blob containers, and then we can actually control who can read and write to these blob containers. Think of this as permissions, right? Maybe you don't want every single person in your organization to be able to read and write to a blob container, because honestly, that's also a bad idea, right? If you have a share all policy, probably not, it's most likely a recipe for disaster in all honesty. So you truly want to be super restrictive with which data you share. Anyways, within these blob containers, everyone, what we can actually create is something called a virtual folder. Now, a virtual folder, pardon me, is not a real folder. It's, hence its name, a virtual folder. It allows us to maintain something called a hierarchy of namespaces, basically, hierarchical data, kind of like the hierarchical data formats that we talked about way in the beginning of this course when we talked about how data used to be structured, right? And this is basically similar to a file system. Do you have a folder setup on your desktop? This is basically the same concept. However, virtual folders are highly restricted. We cannot change folder positions. Like we can't give some people access to specific virtual folders. And we also can't apply bulk operations. And if you think about it, that's pretty bad, right? Or not even bad, that's pretty restricted. Because usually what you can do with folders is you can say, hey, program, read all these folders, delete all these folders, pull all data from these folders. Well, that does not exist in Azure storage or in blob storage. These folders are purely for your own organizational purposes. So just keep that in mind. Virtual folders will not give you the same exact control that real folders will give you. Now, before we talk about ways to solve this problem with virtual folders, which really isn't a problem, it's more just like feature of Azure storage or of blob containers. Before we get into anything further regarding the namespaces, let's talk about three types of blobs. So there are three types of blobs in Azure storage or in blob containers. There's block blobs, page blobs, and append blobs. Let's get into what each one of these blobs or the purpose of each one of these blobs and what they're essentially used for. So block blobs. These are used to store discrete large objects that do not change often. Talking about images, videos, and audio. Block blobs could be composed of up to 100 megabyte blocks per block, essentially. And we can essentially store up to 4.7 terabytes of data within using this type of blob, using this type of block blob. Now, blobs are defined as individual units of data. And the reason that we do this is because it essentially gives us flexibility and also resilience in terms of managing data. We won't go into the technical aspects of why we break up data in blocks, but just know that this is your most basic form of storing data. If you look back here, you'll notice that we have a bunch of images and files that come in the form of block blobs. Cool. All right, next up, everyone, we have page blobs. Now, page blobs aren't actually something that you can create by hand. Instead, we use page blobs for disk storage for virtual machines. Each page is composed of 512 bytes, and we can hold up to 8 terabytes of data using page blobs. Pages, the term page is usually defined as a unit of data that can be individually written to and read from. SQL databases, your computer, they all have pages. But essentially, just think of pages as something that you don't necessarily create. It's really just something that's part of the virtual machine. And lastly, everyone, we have append blobs. Append blobs are, I would say, the most simple form of blobs. These are blobs that we can only append to. Usually used for log files, right? When you have a system that's producing some sort of output or going through some sort of changes, we usually want to log this system and find out exactly what's going on step by step. And that's when we use append blobs. And here we can hold up to 195 gigabytes of data. Now, they're going to ask you about which one is the cheapest form of blob and what is appropriate for what. Just refer back to these notes in order to figure out the appropriate use case for blobs. And one thing to also note is that the larger blobs are always more expensive, right? So you can imagine that a block blob is definitely more expensive than a page blob, which is once again more expensive, than an append blob. Anyways, let's keep moving forward. So, and here's the types of blobs in a nutshell. Okay, now that we talked about the blob types, let's talk about the types of access tiers for each blob. Now, there are three main access tiers, which are hot, cool, and archive. And each one of these access tiers represent how often data is accessed and how long it's meant to be preserved, or basically the longevity of this data. How long is this data supposed to be in the system for? Maybe it's something temporary, like an image that you're using in a PowerPoint slide, or maybe it's something more permanent, once again, like family photos or family records or something along those lines. Now, I use the food analogy in order to kind of, make this equivalent. Hopefully it's a good metaphor. If it's not, just refer back to the actual definition. I found that this food metaphor helped me out there. Okay, so first up, everyone, we have hot tier. And this is the default tier for blobs, block blobs, that are accessed frequently. If you're accessing this data, I don't know, once every hour, once every second, once every minute, hot tier is probably what you want. It's made for instantaneous access. Latency is measured in milliseconds, basically unnoticeable to the human perception, unless you're hyper-trained in noticing millisecond differences. You can think of this as fresh soup, right? It's made for instant consumption. Let's ignore the fact that canned soup exists. Let's pretend that you've already heated up a bowl of soup. it's ready for you to instantly consume. This data is immediately prepared for you. Next up, everyone, we have the cool tier. Cool tier is pretty much equivalent to the hot tier. There are millisecond latency differences between the hot and cool tier, but really nothing too, not too much of a difference unless you really need those milliseconds of latency back. The cool tier entails less storage costs because it takes a little bit longer for you to access this data. I know it says infrequent access and update, but really you're still accessing it pretty frequently because latency is still measured in milliseconds. You can think of this as tomato on a vine. It's ready to go, could be made ready in a relatively few amount of steps, but of course, the soup that you're trying to consume, well, that's ready for you already. Anyways, next up, and lastly, everyone, we have something called the archive tier. This is for data that is accessed rarely, or if not rarely, through long periods of time. We're not talking about accessing it once every minute, once every hour. I'm talking about accessing it once every week or once every month. This is the archive tier has minimal storage costs, and for that price, and for that reason, it also has the slowest access. In order to access this, you probably have to wait around hours for the data to become available. You can think of this as sun-dried tomatoes. It is preserved for longevity. It's not made for instant consumption, even though you can still eat sun-dried tomatoes as a human instantly. So that analogy kind of falls apart there, right? Anyways, but let's say you do want to prepare these sun-dried tomatoes in the soup. Let's say you do need to rehydrate them. I don't know if sun-dried tomatoes can be rehydrated, but archive tier does need to be rehydrated. This is what the hot tier looks like. Notice how the data is made instantly available. This is what the cool tier looks like. Once again, made instantly available, but just a little bit cheaper. And here's what the archive tier looks like. Notice that it's not available. And if you do want to make it available, you need to rehydrate your data. And here's the differences between hot, cool, and archive. I know we have a cold tier here, but we're going to ignore the fact that that exists. Notice that they all share the same amount of availability. I guess the hot tier has that 0.9% compared to the cool tier. Once again, everyone, if you're just storing data and you need this data to be accessible and you're not a Fortune 500 company that needs those milliseconds of data and you're willing to pay $300 million for 3 milliseconds of data or less latency, 3 milliseconds less latency, then cool tier is perfectly fine. Anyways, and yeah, once again, notice how all of the tiers, their latency is measured in milliseconds. However, for the archive tier, it's measured in hours. All right. So next up, everyone, we have a quick review question that's actually a real DP-900 question. They're basically asking you to drag and drop the correct term in the hierarchy. And this is for blob containers. I want you all to pause the video, think about the answer for a second, and then we'll go over it and see if that's correct. All right, so hopefully after Azure Resource Group, the very first thing that you're going to place is the actual resource. Now let's think about this. What is the resource for blob containers? Well, that is going to be Azure Storage Account. So this goes in position 1. And then finally, if you want folders and files, well, that's actually going to be, well, actually, let's see here. Oh, pardon me. Okay, this isn't for blob containers. This is actually for file share. So file share goes second. Anyways, let's keep moving forward. All right, next up, everyone, we have data lakes. Now, keep in mind that previously we were talking about virtual folders and the limitations of virtual folders, right? They're good for naming your hierarchies, but other than that, they really don't serve any other purpose. Well, this is where data lakes actually come into use. So here's a discussion question. Why would we want a share everything architecture on our enterprise network? Good question, Farouk. Maybe the answer is you don't want a share everything architecture on your enterprise network. But anyways, we won't worry about that. So essentially, everyone think of blob storages as a very simple way to store blob files and different types of access or blob files underneath different types of access tiers. However, they don't really support any sort of complex file storage, and they also don't support any sort of analytical support. Blob containers are a very simple way to store your data. So if you do want to put a layer of analytics on top of it, and you also want complex folders where you can manage different permissions, well, that's when you're going to want a data lake. So if you're interested in scaling up your analytical capabilities, and if you're also interested in making a more complex unstructured data store, data lake is your best bet. And in order to do this, we need to upgrade our blob container to something called Azure Data Lake Storage Gen 2. Now, how do we turn our blob container into a data lake? It's actually really, really simple. All you need to do is go into your settings and essentially enable something called a hierarchical namespace. And that's really all that there is to it. And by enabling a hierarchical namespace, essentially you convert your blob container into a data lake. Now, what is the benefit to creating a data lake from your blob container? Well, instead of having virtual folders, you then get the ability to have real folders and real directories that you can manage via permission access. You can also run high-performance analytic operations using various abstractions such as MapReduce and HDFS, or rather Spark. And finally, you can also apply atomic operations on folders. Essentially, you can apply those batch operations that you weren't able to apply using simple blob containers. And essentially, all of this, you get all this with relatively very little downside, other than, of course, the cost, right? Keep in mind, this is Azure, this is a service that you're paying for. So, of course, if you enable hierarchical namespace and you start doing a bunch of complex operations, of course, you're going to start paying more for your Azure account. All right, and here's an actual Azure DP-900 question. An Azure storage account must have what enabled to support Azure Data Lake Storage? Blob soft delete, hierarchical namespace, large file shares, or versioning? Pause the video, think about this for a second. All right, and your answer should be, hierarchical namespaces. Keep that in mind. When you want to enable data lakes from blob containers, you just need hierarchical namespaces. All right, next up, everyone, let's talk about Azure Files. So Azure Files is, again, a pretty simple concept. And keep in mind, we're still talking about the concept of storing various types of data. Talk about relational databases. We talked about unstructured blob containers. Now let's talk about unstructured file storage. Think about Google Drive. Think about, let me think about other types of file storage. Yeah, we got Google Drive. I think Outlook or Microsoft Outlook has some sort of storage. iCloud has a storage. Basically, all of those simple storages that we use for our own personal uses, Azure essentially has that as well. And it's called Azure File Storage. You can store up to 100 terabytes within your account, which is really a lot of data. And I don't think any one person has 100 terabytes of data to store. And once again, this is made for enterprise solutions. And the maximum concurrent connections per file, basically how many people can interact with the same file, is 2,000. So really, we're talking about large-scale data sharing at this point. 2,000 people can interact with the same file at once, and you can have 100 terabytes of data at most. All right, and now there are two types of file storage in Azure. You have the standard hard drive-based storage, which is super cheap, and then you have the premium solid-state drive based storage, which essentially supports fast access. It's very resilient, and it's also not cheap. However, if you have just basic files that really don't need any heightened, redundancy, hard drives should be good enough. Next up, everyone, we're going to talk about some transfer protocols that we can create via Azure File Storage. First up, we have the server message block. which is just file sharing across Windows, Linux, and Mac OS. And then you have network file system. Now, I myself am not any sort of network engineer, so I can't really tell you what makes these two types of things special. But I can tell you which OSs you can use these transfer protocols with. And with network file storage, you can only, or network file system, you can only share files across Linux and Mac OS. And it's also only accessible if you have the premium version of Azure File Storage. And then we have this super pixelated image that we're not going to talk about today. And finally, everyone, let's just talk about something called Azure Tables. So we talked about relational databases, right? And we talked about different ways we can store data within rows. But if you really think about it, relational databases are sometimes overkill for what we're trying to do, right? Do we really need normalization? Do we really need a SQL, query language to interact with the data? Maybe you just want to store CSV files that are not normalized and purely for analytical reasons. Well, in that case, what you would actually do instead is store your data in something called Azure Table Storage. You will be able to store your data via rows and tables and access tabular data remotely, via a different machine without having to worry about relational features such as normalization, foreign keys, primary keys, procedure reviews, indices, things like that. This is just basically the most basic form of table storage without any of those relational database considerations. Now, in Azure Tables, we do have to keep in mind that data is stored according to something called partitions. And essentially, when partitions are specific subsets of our tables that are independent of one another. And this essentially allows us to speed up our queries. And in order to access specific queries or access specific points of the data, we could, or pardon me, specific information from our tables, we can either use something called a point query, which gets us a single row, or something called a range query, which gives us a contiguous range of rows. And we do this via the Azure Table Storage API, which is essentially a programming interface. It's not too important to understand what this API looks like. It's just important to note that there are two types of queries that we can execute via Azure Table Storage. All right, so for each row, everyone, we need to specify three discrete things: the partition key, which designates which partition a table belongs to; the row key, which uniquely identifies the row; and finally, the timestamp, which is just simply a generated timestamp of the last modification. And using different partition keys, everyone, we separate our data into different partitions, which once again helps us speed up our queries and also heightens the security and data integrity of our tables. Now, the question might be, why? Why in the world would we want to store data in Azure Tables if relational databases are right there? Really, it comes down to a question of cost and usage, right? So once again, if you have the ability to make OLTP databases, why bother with tables? Well, take a look at the difference between prices. For a basic relational database, you're spending 12 cents per gigabyte per month, whereas with Azure Tables, you're only spending 4 cents. Well, if we round it up, 5 cents per gigabyte per month. And if you multiply this by thousands or millions, you'll quickly see what the utility is between one service or another, right? So that's why it's always important to consider, what am I trying to accomplish? And what are the specific tools? What are the most cost-effective tools that I can use to accomplish this, right? Sometimes engineers talk about paying for their own salary by finding things to save, or basically saving company costs. So for example, let's say your company or a company that you're entering is using OLTP databases on Azure, and they're spending, let's say, $1,000 per month on this cost. And in fact, let me actually do the math really quick. Let's say they're spending $1,000 per month on relational databases. And let's see how much that comes out to gigabyte per month. All right, so they have 8,333 gigs. And let's say it turns out that they're using OLTP databases for no reason. Essentially, they're not making any use of normalization. They're not making any use of primary keys, foreign keys, things like that. They don't need any sort of relational database connections and other service to support their operations. Well, that's when you can come in and say, hey, everyone, why are we spending $1,000 per month on OLTP databases when we could move to Azure Tables and instead only pay, let's do some quick math, $375 per month. Wow, amazing. You just gave them back, quick math. You just gave them back $625 a month for them to play with, which then totals out to $7,500 a year. Excellent. You just paid for part of your own salary. All right, and once again, everyone, that's a very highly simplified version of how things actually work, but still is something that exists. Let's take a look at this review question. You know what, actually, let's save this for until we get to Cosmos, which is what we're going to get into in the next video. All right, thank you all so much for following along, and I will see you all in the next video.